We'll talk about curl in calculus, rather we'll continue the curl in calculus, and we will talk about circulation density while we are calculating curl. Curl, circulation density, curl, circulation density. I have okay, so I have few things with me. What is this? This is a iron. This is an iron. What is this? This is an iron. I mean, looks like a lock, but this is iron. This is iron. This is, but they look like steel, right? I mean, I, I have a pair of magnet. Okay, so I'll try that if it is iron or it is steel. Okay, so this is iron, not steel. Looks like steel, but this is iron. And this is also iron. Now I'm asking someone, I have these two. Now I'm giving to someone, and he's saying, I'm saying this weight of this steel is 100 grams, and weight of this steel is 10 grams. Okay. Now, but he is not interested in 100 gram or 10 gram. He's saying, I'm going to melt it anyway. I don't want your lock, or I don't care. I don't care your whatever the iron is. I'm going to melt it. Okay. What is the quality of the iron? I mean, this is lock and this is some kind of a wire. No, no, no. I'm not talking about wire or lock because I'm going to melt it. What is the quality of the iron? What do you mean by quality of the iron? This is 10 gram and this is 100 gram. So, what do you mean by quality of the iron? Quality of the iron, what I mean is this is big, this is small. So, this, if I take this 1 centimeter by 1 centimeter by 1 centimeter, okay, because I'm going to melt it, right? And if I take it 1 centimeter by 1 centimeter by 1 centimeter, then what is its weight? Oh, you're talking about density. Yes, I'm talking about density. Density gives the quality. If this has higher density, then this quality is higher, even though it is 10 grams. If this density is lower, even though it is 100 gram, but the price will be different. The quality of this is higher, quality of this is lower, because the way I am calculating the quality is the density. Density, what is its density? I am not compare. I believe it is all right. You can compare two animal and check their brain density. I'm not saying compare to human brain density. I believe every human, they are same, but every animal are not same. Human and tiger are not same. If I consider human as animal, their brain density would be different. Density is big thing. Density is very big thing. Okay, now I have two magnets. So I have two magnets. Oh, two, two magnets. This is also iron. Can you see this? And okay, what is density of this? It is very lightweight. Looks like very big compared to this, but it would be 5 gram only. It is very lightweight. So density differs. Now I have two magnets. and I am going to, oops, now this is iron, and now one magnet I am trying and seeing that how much is the force through which this is, now this, okay, this is better example. This is very lightweight. If I keep a magnet, then can you see this? I believe. Now, if this is a magnet, then automatically it is going towards magnet. Okay, magnet is pulling this. So if I keep at a distance and I leave it, it pulls it. Okay, I have now another magnet. Okay, now I'll keep at equal distance and it pulls it. But what is the force through which it pulls it? I have one more magnet. This is clock, but this is not working. Okay, so we can try. Don't try with the working clock. So here looks like backside there is some magnet. I'm keeping it. Okay, but it is pulling through very less force. But see the size. But this is pulling through higher force. Okay, what is the quality of the magnet? What is the magnetic density? If I take 1 centimeter, 1 centimeter, 1 centimeter cube of a magnet, then how much is the force? That is the quality of the magnet. Magnet has quality. Iron has quality as far as its density is concerned. Iron density in terms of weight, where magnet density in terms of magnetic pull, force. So this is called density. Okay, now I am back to the pavilion. So this is force field. This is force field, and this is x-axis. So this is x-axis. I mean, I'm not showing the white one. This is x-axis. This is force field. This is x-axis, and this is force field. Magnetic field or vector field. Vector field is algebraic vector whose components are algebraic equation or function over independent component x, y, z. If it is three component vector. Now, now there is a circle. This is circle. Now, what is, okay? This is force field. This is force field, and this is circle. What is line integral of this force field or vector field along the full curve? That is point A to A in a closed loop. In a closed loop, what is the what is the what is the vector field line integral? Vector field we are talking, right? If I multiply vector field with distance, then it is called line multiplication. Vector field, power of the vector field multiplied by the distance. Or if vector field if vector field is in different direction than the displacement, then vector field is capital F and displacement is r vector, then capital F dot r vector. Whatever comes, the dot will bring you the kind of magnitude one. So whatever comes, that is called line integral. Line integral of vector field along the line. If both are, I mean, I talked about vector, not vector field. If this is a vector and I'm trying to calculate this vectors multiplication along another vector, then vector f, that is this vector dot product of the displacement vector. Now, if vector is vector field and this displacement is again a vector field, then capital F dot, not r vector, dr vector. Now it comes as calculus because things are changing as per the independent variable x, y, and z. If I change independent variable x, y, and z, then vector field will keep producing different vectors. Similarly, displacement will also keep changing. If that is the case, then if this is the displacement vector, then every moment the line integral is different, because vector is different. Here vector is like this and displacement is like this. Here vector is like this and displacement is like this. Here vector is like this and displacement is tangential. So every moment displacement vector is different and vector field or force vector is different. If I am calculating work done, that is the capital F, that is the vector field. Capital F is vector field. So capital F vector field dot displacement vector, this dot product gives me work done. Or if I just say line integral, then vector field dot displacement vector, capital F dot dr vector, that is the calculus vector field line integration from point A to point B, integration from point A to point B, capital F vector dot dr vector. Okay, if that is the case, then this is called line integral. Now, if I am calculating in a closed loop, in a loop line integral from point A to point A only, from point A, full line integral, if this is vector field, capital F dot dr vector for the full path coming back to A, integration from A to A, capital F dot dr vector, where r vector is a circle. This is called line integral. Line integral. Line integral. This is called line integral. Make sense? Okay. Now, I'm taking another shape because I want example to be simple. Now, I'm coming back to rectangular only. This is simple x-axis and this is point A. Point A, this is x-axis. Now I want point A to point A closed loop integral. Closed loop integral means point A, I consider A and B here only. A and B here only. A, B. If I take counterclockwise, then A to B, B, B to C, top point is C, C to D, D to A back. This is the line integral. A to B, B to C, C to D, D to A to A. Line integral from A to A, capital F vector field dot dr vector, where vector field can be a force field also. If that is the case, then net result is work done. It will result, integration will result into potential function, or you can say potential energy function, whatever it is, if it is force. Otherwise it is called potential function only. This proves that this line integral is most famous in force vector field. That is the concept. Now consider the vector field capital F. The vector field capital F, vector field capital F is x plus y I plus 0 j. It has only I component. So vector field is always in I direction wherever you take. But if you take on x axis x plus yi, this is the example I have been taking. This is the example I have had been taking. Anyway, so x point A to B. Now the vector field is, the line is A to B, B to C, C to D, D to A. This is the line. I have four things if I calculate the line integral. A to A, lower limit to higher limit, one point to another point. So two things are there. A to B, one point to another point. Then capital F vector field dot dr vector. Four things. R vector, capital F, A to B. Four items comes when I calculate the line integral. So if I am calculating line integral here along x axis, then A to B, capital F has two components, x-axis component, I component, j component. I component is x plus yi. Capital F equal to x plus yi plus 0j means F1. The first component of capital F1 is x plus y. The second component F2 is 0. So now if I am calculating capital F dot dr vector where point A to B, then r vector is along x-axis xi plus y 0j because y is 0. So xi d of xi will become dxi, and here f1i plus f2j. Anyway, there is no j also in the on the x-axis. Okay, so it will become f1 dx, x plus y dx, x plus y dx. Y is 0, so the line integration here is x dx, that is x square by 2. So A to B, the line integration is x square by 2. B to C, this is the next direction where the force field has only I component, J is 0. So force is like this. I mean vector field is like this. If that is the case, then we don't have F2. If we don't have F2, then if I take this form, then along this line every point is x comma y because x is there, y is there. So the line is a form of dr vector will converted into dxi plus yj, dxi plus dyj. Here f1i plus f2j. F2 is not there. So if f2 is not there and f1 is there, okay, so on this side if I am trying to calculate the line integral, then the formula of this line is along the y-axis. So I am saying point is x comma y is there, but if I take the vector notation means I have to take the vector notation, r vector, right? If I take any point here that is x, x2, y2, and any point here, I'm trying to calculate the vector x2, y2. Vector is you just subtract the 2 points x2, y2, and here it is again x2, y2 because x is same. Then vector will be in j direction because x component are same. So then vector will be in j direction. So dr vector will be only in the j direction. So x component goes away. X comma y, I was saying there is no x comma y. I mean there is no xi plus y. It is only yj. X is not there. So x would be there if some constant or something like that. So d of xi plus yj, then x is not variable. I can take x, some constant numeric value, some 10i plus yj. Y is variable. So it will become d of 10i plus yj will become 10 becomes 0 or differentiation, and it will become dyj, whereas f1 is x plus yi plus 0j. Net dot product is 0. So if I have a vector field that is in x-axis direction, I am trying to calculate line integral along y-axis, it will result into 0. I am trying to calculate line integral of this rectangle. So first line integral is x square by 2. Next line integral is 0. Next is C to D, and vector field is x plus y I dxi dot dxi. Okay, because along this side y is constant. If y is constant, then dy will go away. Here, what is the y? Y I consider 10. So force vector field is x plus 10i plus 0j because vector field f has only one component, that is f1. So x plus 10i d of xi, because x is variable, d of xi plus some y, that is 10j. If I do differentiation, it becomes dxi plus nothing, and here f1 I plus nothing. Now I can do dot product and it becomes x plus 10 dx. X square by 2 plus 10x. Certainly the line integral here, that is x square by 2, that is along this direction, and line integral here from here to here, it is x square by 2, x square by 2 plus 10x. C to D, C to D means x, C to D means x, x, C to D. C is higher, D is lower. So it will come in negative fashion. This proves that this side, along the fourth side, it is positive. Otherwise, it is negative. So I had taken this direction from this side to this side. A to B, B to C, C to D, D to A back. A to B, x square by 2 positive. 0 and then x square by 2, 10 plus 10x, 10x, C to D, okay, C to D, it is coming as negative. So if I take D to C, it will come as positive. So x square by 2 plus 10x D to C, same direction A to B, I had taken D to C, then it will be positive and it will be powerful than this work, this line integral. So net line integral, then this again 0, this 0, this 0. So net line integral will be this, this one plus this one, that is 0, plus this to the, that is negative, and this to this. So net line integral will be negative plus positive, then it will be more negative in this direction. So positive in this direction, whatever it is. Net result is whatever is the line integral here minus line integral here. So this portion line integral is more, this portion line integral is less if I take in same direction. So I have to subtract this. That is the net line integral of this kind of this rectangle. If force was xi plus 0j, not x plus y 0j, xi plus 0j, then line integral here and line integral here are same, and c to d negative means this plus this will be 0. So net line integration from a to a will be 0. But now the net line integral from a to a is not 0. Can we see it? It is not 0. And line integral here in this direction, it is more. So if I subtract this, that much is the net line integral of this rectangular line with a force field, that is x plus y j. So what is that? X square by 2, x square by 2, or x dx plus 10 dx minus x dx. It will come as 10 dx, 10 dx, that is 10x. 10x is the line integral from D to C. From D to C, whatever is the calculation, that is the net line integration we are getting. What about minded? Consider this is A to B and B to C. C is here only. C is here only. Then calculate the line integral. B to C, C is here. C D E, C D A back. Now A to B, C is here, very far, and then calculate the line. Are they same? No, they are not same, because the net line integral dependent upon the y factor. Here it is x dx, here also it is x dx plus whatever y, if y is 1, then 1 dx, that is the net, because x dx are getting cancelled out. So whatever is the height, that much dx is the net line integral. So if I make this rectangle higher, bigger, the line integration is growing. What is the factor that it is growing? The way y is growing, df1 by dy. If f1 is the ith component of the vector field, then how much this f1 is changing as I am changing the y? This is called df1 by dy. If df1 by dy is 0, then line integral will be 0 because vertical component anyway it is 0. Horizontal component, if df1 by dy is 0, then net line integral will be 0. Make sense? Anyway, we are talking about circulation density. Now, someone is asking, what is your, I have a vector field capital F. I have a vector field capital F. What is the line integral of a rectangle? Okay, it is some 10. Very nice. Okay, now someone says, now I am asking, what is the line integral of vector field capital F? Now, he tried with the smaller rectangle, now he trying with bigger rectangle and he is saying 20. How come it is? Vector field is capital F, how it can be 10, 20, 30, 40, 50 the way you are saying? Okay, sorry, I took this much the height, I took this much height, this much height, this much height, where vector field is x plus yj, x plus yi. If he is making different height rectangle, then net line integral is changing. But we are not able to catch the nature of the vector field. Can you see the nature of the vector field? If I am doing the line integral along the rectangle where height is changing, then line integral is changing. At least I found that this vector field has line integral. It is not path independent, because if I calculate A to A to B, B to C, C to D, D to A, integration from A to A should be 0 as per the calculus. If I am taking some path, loop path, and it is not 0, this proves that vector field is not path independent. If vector field is not path independent, it will generate rotation. Rotation in the sense that vector field here, if I calculate force field, then force is less. If I calculate force field here, because y is there and force field is x plus y I plus 0j, then force field is higher. Consider this is a river. This is a river flowing from left direction to right direction, minus x-axis to x-axis. And near the bank of the river, okay, near the side of the river, the flow is less, the force is less. If you go at the center, the force is higher. If I place any item here, it will go along the river, but it will rotate also. Because force is higher, force is lower, it will try to produce torque. This is in physics term, but in calculus term, it will provide rotation tendency. This river has rotation tendency. Don't go inside it. If river has rotation tendency, don't go inside it, means, by the way, if you try to swim, then your body will be afloat, right? If you try to swim, your body will be afloat. If body is, if this is a river, and if your body is afloat, then both end of the body, human body, the force will be different. The line integral, what we are calculating, force into displacement, the work done by the river. River will do work if river has force, and river is making displacement on you. River is doing work done. The work what river will do at each point of the human body, if human body is afloat on the river, that will be different. It will create rotation. The person will move along the river and he will keep rotating. If rotation tendency is very high, then it will make whirlpool, okay, swirling. This is kind of curling factor, but we are talking about the nature of the river. So I am saying, how much is the speed at which a person is rotating? Someone can say he is rotating at a speed, angular speed of x. Okay. Now some other one kind of rotation is very small, so a human can go. So one human went there and rotation, or better I take a boat. So boat I placed like if this is the river, if this is river bank, one bank of the river here and one bank of the river here. River is flowing minus x-axis to y-axis. Now I place boat like this. If I place boat like this, and then I am asking that what is the angular speed of the boat, then someone would say it is x. x x is the angular speed, whatever its unit is. Okay. Now Then he tried something else next day, and someone is asking what is the angular speed of the boat. Why? Arey, how come it can be? Why? Not possible. River is same. Then how it can be x, y, z? So many alpha, beta are the angular speed people are talking. Then when he sees it, then the boat what he had taken to calculate the angular speed, boat's length is different. If boat length is different, then df1 by df1 by dy would be constant, but y is varying. So df1 by dy, net work done in a loop, closed loop, will be more. Net line integral will be more. So more it will produce the angular speed. No, no, tell me the nature of the ring. I'm not talking about angle, because every time you are trying different boat and you are bringing different kind of angular speed. I want nature of the river. You remember, I was trying to calculate nature of the iron. What is the nature of the iron? What is the nature of the iron? I'm not talking about the net weight. I'm not talking about the net circulation. I'm not talking about the net circulation. Tell me the nature of the vector field generated by the river has nature. If you calculate the nature, then you come with the the line integral density. If someone calculates line integral density, then he is calculating the nature of vector field. So if this is a point and this is b point, if this is a point, this is b point, then it is forms a rectangle. A to B, B to C, C to D, D to A back. Okay, if that is the case, whatever the line integral I have calculated, if I divide it by area of the rectangle, if I divide it by area of the rectangle, then it gives me the nature of the vector field. So if whatever the line integral I am getting from A to B, B to C, C to D, D to A back, okay, if height is less, area is less. Height is more, area is more. Height is more, area is more. If height is less, line integral is less. Height is more, line integral is more. Height is more, line integral is more. But the nature of vector field is same. If you want to catch the nature of the vector field, whatever the line integral you are calculating, divide it by the area. I would say, no, 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 I am not interested in dividing it by area. I am happy with dividing with height only, because height I am wearing. Very nice. Someone would say, I am not going to divide by area. Why I want to divide by area? Height is varying and this is what I am getting. Why we divide by area? To get the nature of the vector field. Do you remember that we made these two sides silent? Because vector field is capital F in x plus y I. Only first component is there. If it is x plus y I plus x plus sine y j, x plus y I plus x plus sine y j. If this is the vector field, then this line integral and this line integral will not be silent the way we did. If that is the case, then line integral along this side and line integral along this side, they will also try to cancel each other. Line integral along this side and line integral along this side, they tried to cancel each other. This was more powerful. So line integral of this one minus this one, whatever was the remained, that was the line integral along this direction net. Like this is the direction. This direction, this direction, this direction, this direction. Force is in this direction. Earlier force was in this direction. Now y component is also there. So vector field is in this direction. If that is the case, then this direction, whatever is the line integral, again they will try to cancel each other. Whoever is more powerful, that way it will take. So certainly, if x is growing in this direction, this will be more powerful. Whatever is I am getting after subtracting this line integral with this line integral is the net line integral in this direction. This line integral now, from this and this I am getting net line integral in this direction. From this and this, I am getting net line integral in this direction. They again try to cancel each other. So what is the line integral difference I see from this to this? This two line integration happens through F2 component, not F1 component. Vector field capital F equal to F1I plus F2J. So F2J produces line integral along vertical. F1I produces line integral along horizontal. Then net line integral through vertical, net line integral through horizontal, they try to cancel each other at the end. What is the line integral difference I see from horizontal side? That is df1 by dy. That is the factor that triggers the net line integral. What is the factor that trigger line integral along y direction? df2 by dx. If this is f2 of the vector field capital F, what is f2 here? Consider this, a point is origin, then x is 0, then it is sine y is the vector field f2. If I go x is 10, then it is 10 plus sine y. That's why here work done, line integral is more, here line integral is less. If that is the case, then this line integral is sine y dy. I mean here it is 0 plus sine y. Here it is 10 plus sine y. So sine y dy is gone. Here also sine y dy. Only by how it will surpass this line integral in x dy. If x is 10, then 10 dy, 10y. Like this here, it's this side surpassed it by 10 dx, 10x. So 10x is the line integral along this side and 10y is the line integral along this side. Net line integral is 10x plus 10y. If x net line integral is opposite. So 10x, x is 10, then if x is 10, then it is 10 minus 10. Net is 0. Net is 0. But I have not taken the limit. Considering a to b and b to c, this height and this length is constant, same. So 10x, the integration of 10x from a to b. So I consider a to b is unit, c to d is, b to c is unit. Then 10x minus 10y. Then it will become the kind of net line integral is 0. If it is 0, then it is path is a candidate of path independent. But if it is not 0, then it is not candidate of path independent, whatever it is. What is triggering the line integral to change from this to this? That is df1 by dx. If it is f1, how f1 is changing? I am changing x. What it is triggering the line integral difference from this point to this point? df1 by dy. How much f1 is changing if I go along y-axis? How much f2 is changing if I go along x-axis? That is it is triggering the difference between this and this. df1 by dy is triggering the difference between this and this. Net is what we get the line integral. What is the net line integral? If I am saying df2 by dx, df1 by dy, then what is the net line integral? Whatever it is, we will see everything. Now we were calculating that if I calculate, now you tell me, earlier I was increasing y and I was getting different line integral. So I said whatever the line integral you are getting, divide by y, then you will get force field nature. But now it is changing in x also. That is the net. So x and y, if both are changing, then I have to divide by area. So df1, then the net line integral, whatever we are getting, if I divide by the area, then we get the nature of the vector field. Line integral in a loop, whatever line integral I am getting in a loop, whatever line integral I am getting in a loop divided by the area of the area that this loop is making. Okay, so if consider this is a to b and this is b to c, then area is a to b and into b to c, because other will be same. That is the area. So whatever line integral I am getting, divided by A to B length into B to C length. What about this? And this is the vector field. What about this? Then whatever the line integral I am getting from full in counterclockwise, full the circle divided by the area of the circle. This is called line integral density, or if I rename line integral as circulation, what you are trying to do? I am trying to calculate the circulation. Circulation is same word, synonym of line integral. Then it is circulation density. Circulation density, the line integral from A to A back, whatever I am getting, that is circulation divided by area is circulation density. This gives me the power of vector field, how much it is. Okay. So now it does not matter if it is density, then I am taking a small circle because it is talking about the density now. If I am talking about density of this iron, then doesn't matter you take 100 kg iron or 10 gram iron. Density is different factor at all. If I take 1 unit length, 1 unit height, 1 unit width, what is the weight of this iron? That is the density. If I am talking about density of the circulation, what I have calculated, it doesn't matter. Either it is so small circle or it is bigger circle. After all, we are talking about density. If it is density, it talks about the power of the vector field. What is the circulation density of the river? Don't talk about the angular speed what you are getting. Your boat size will be different. I don't bother. What is the circulation density of the river? That is in question. If it is very high, then certainly it will be written in the board, circulation density of this river is very high. Don't go inside it. Otherwise, you will keep making a circle inside that. Circulation density means what is the tendency nature of this vector field to make someone rotate. That is the circulation density. If circulation density is nature of a vector field to make something rotate, and curl is also a nature of a vector field to rotate, then both are same. Circulation density and curling factor both are same. Means line integral capital F, line integral capital F dot dr vector along a closed loop is same along a closed loop divided by the area where area tends to 0. That is the best word, where area tends to 0, because I'm not bothered about area now. It is very big, very small, doesn't matter. If it is smaller, it will be better calculation. So integral in a closed loop capital F dot dr vector, capital F vector dot dr vector, whatever the circulation or line integral is coming, divided by the area. Area tends to 0. That is the case, then it is this circulation density is the, if circulation density is the nature of a vector field to make something rotate, it is same as curling factor. If that is the case, then it is same as df2 by dx minus df1 by dy. df2 by dx give me the tendency of this vertical side to make something rotate. df1 by dy give me tendency of something f1 to make something rotate. If I subtract these two, then it give me net tendency of this vector field to rotate. So that is df2 by dx, this tendency to rotate in this direction, minus df1 by dy, this tendency to rotate in this direction. If I subtract, then I get the tendency of a vector field to rotate something in counterclock direction. df2 by dx minus df1 by dy is nothing but claiming something to rotate in counterclockwise direction. df1 by dy minus df2 by dx is tendency of a vector field to rotate something in clockwise. df2 by dx minus df1 by dy is tendency of a vector field to rotate something in counterclockwise. So circulation density is nothing but curling factor, that is df2 by dx minus df1 by dy. If that is the case, then circulation density equal to equal to curling factor df2 by dx minus df1 by dy, where circulation density is line integral by area. If I take area on right side, then line integral equal to the curling factor into dA. Area tends to 0 means delta A. Delta A went that side. dA, df2 by dx minus df1 by dy, dA is the net line integral. This is what the Green's theorem is, right? The line integral capital F dot dr vector by delta A is circulation density. If circulation density is same as the tendency of a vector field to make something rotate, and it is same as curling factor, then it is equal to df2 by dx minus df1 by dy, tendency to rotate in counterclock direction. Then this line integral by delta A if I take on right side, then it becomes df2 by dx minus df1 by dy, that is the curling factor curl dA. If df2 by dx minus df1 by dy, dA is now it is same as line integral capital F dot dr vector. Is it not the same as Green's theorem? Okay, we'll talk more about it, and we'll talk about Stokes' theorem. Many things. This is commercial calculus because we are coming into commercial picture. Now, if I am kind of if I am planning of making a around a river, resort around a river, and some people are facing bad time when they are entering into the river. Now, I can put a board that don't enter into the river because you may die. You may die. Now, no one will go to your resort. Who will go to your resort when the center of attraction is the river that is flowing inside your resort, and anyone enter, he dies? Then, but now you are placing that don't into the river because it will circulate you, it may kill you. The circulation density is X, whatever it is. Now, any person who is very powerful in swimming and it is X and his strength is X plus 100, very powerful, then he will enjoy it. Now, if you say this river has circulation density of 10 and he has power of crossing a river of circulation density of 100, then certainly it will attract lots of people. But if you say don't enter, it may kill you, then you will be penniless, okay, whatever it is. So, curling factor is entering into the commercial calculus where you think about direction, magnitude, and so many things. We will continue this discussion.